That was such a great podcast. I've been sitting down with Gil Rhodes at RPEQ, which is a registered practicing electrical engineer from Queensland. He flew down from Brisbane, got here this morning, and we got stuck right into it. What I really like about Gil, and he is a good friend of mine, is his breadth of knowledge and his understanding also, not only of things that are engineering related, electrical engineering related, but the human condition. We talked about his early days as an apprentice to his father working on Stradbroke Island, his time in the surf life-saving arena, and he's still connected to that at a pretty high level. Also, his number one passion, apart from his family obviously, and that's brewing beer. Technical stuff, we went absolutely crazy. We talked about the requirements of these large-scale 1 megawatt plus commercial solar system, AC cable tray and AC cable relationships, inverters, no neutrals, HV. We covered the lot. Please do yourself a favour, sit down, strap yourself in and listen to what unfolded in one of the best conversations I've had in a long time. And by the way, don't forget to like, subscribe and comment, and that allows us to keep on making these pretty decent podcasts. A big shout out to Ayuka, our amazing cinematographer and videographer, and Mr. Renewable Energy himself, one of the hardest working men in renewables, Mr. Andrei Sablinskis. Sit back, as I said, this is a real treat. So, Gil, I know you do PowerCAD, and I know there's only two people in the whole entire world who do PowerCAD. Can you give me a background of what PowerCAD is? Two, why the heck are you the only other person to do it, apart from the owner? And three, see point 1 and 2.
All right. Well, okay. So PowerCAD was the brainchild of Adrian Newman, who's Melbourne-based, and he was a consultant, very good, very in-depth, very detailed building services consultant for many, many years. And around the early 90s, he said, okay, there's got to be a better way to do this. And so he started developing PowerCAD software. And with that, it sort of developed through the years and became like a really good product. And, obviously with Windows and the different formats of programs and all that sort of stuff being developed, especially through the 90s and the early 2000s, it sort of went through several iterations and eventually came out the way that we see it these days. And so, it's been going for, more than 30 years. Adrian actually, unfortunately, sold the business a couple of years ago to a Canadian software company, and it's a family-owned software company. They're fantastic. They're lovely people. And they want to keep the software going. They want to develop it. They've got a big suite of all these different products, and they think it's just complementary into what they do. And so, up until that point, or actually, when was it? 2021. So the story of me getting into becoming one of the PowerCAD trainers
starts now.
Starts now. So what happened was that, as everyone knows, we were going through COVID. We had Brisbane. Brisbane was still open. Queensland was still open to a degree. And the demand for training had been very, very high because of the fact that we'd all been locked down since March 2020. And so Adrian was like, okay, fine, we're going to go do some training in Brisbane. He organised some training in September of 2021, 2 days up there, and it's a day course. Starts about 8:30 in the morning, finishes at about 5. And he was planning it all, and I think it was about 5 weeks before he was due to come up, Melbourne went into a big lockdown, and it was a pretty big one. It was going to stay locked down for a while.
Tell us about it.
Yeah, I could imagine everybody would be familiar with it. And so he gave me a call, and bear in mind, this is after many years of actually working very closely with Adrian with the software and doing a lot of, I'd always do his beta testing for him, and I actually held the record for the quickest turnaround on a bug after a download. I think it was like half an hour on a Monday morning. I'd found a bug and sent it back to them, and they were like, oh yeah, here it is. Fix it, new version on the server and everything like that. And so worked in very well with them, knew the software. I've been using it since, myself had been using it since 2008, so since I started AGR Electrical Engineering. And he just rung me up and said, look, there's you and one other person that I'd probably trust to do the training. Are you interested in doing it? I said, oh yeah, I'll give it a crack. So we spent those few weeks leading up to the training, coordinating the efforts, he made sure that I had everything, all the details, all the notes, making sure that I was ready to go. I did the first, the first day, did the second day. The feedback came back really positive, and he goes, how about you do this from now on? I went, okay, I'll definitely do that. I'm happy with that.
I'm surprised that the feedback came back that. I'm surprised at the feedback that came.
Careful.
I was leading up to a joke, but I've fallen flat in my face, so I'm going to stop. Look, I mean, I think let's jump back a bit, because we actually haven't explained what PowerCAD actually is and who uses it and why do they use it. Yeah.
So PowerCAD is electrical engineering design software. And the thing that makes it unique, I mean, we can reference the standards, we can put together spreadsheets, there's other products out there that can do that sort of thing. What PowerCAD has in its uniqueness is a lot of manufacturer data, behind the scenes. The old adage, RTFM?
Yeah.
Read the manual?
Yeah, absolutely.
That's right.
Yeah.
So there's a lot of manufacturer information behind PowerCAD. So PowerCAD actively engages with all manufacturers and says, hey, you give us the data. Sorry.
That's all right.
It's the hands.
That's fine.
Sorry. It's and so actively engages with all the manufacturers to get the information in and make sure that it's all correctly represented, and to make sure that everything sort of works together. Now, PowerCAD is very unique, is that it does checks and balances according to the standards with manufacturer data. So, manufacturers, they will guarantee their products, no problems, like, coordination, backup protection, all that sort of stuff. PowerCAD, you can do a coordination study with different manufacturers at different levels in your distribution system as well. And, the complexity that you can actually add into a PowerCAD model, like, I demonstrate that during the training. I've got one job which was a fairly massive distribution centre in Brisbane, and 6 transformers, 6 main switchboards, just over 250 switchboards on site.
Wow.
And it did everything in there in one file, one model, no problems. So it's, all the switchboards, circuit breakers, cables, all the different checks that you do, like, your prospective fault levels, your trip settings, earth fault loop impedance, that sort of stuff as well too. So it's a package that you can do an electrical distribution system design on, and then get some very good information out of.
So I'll just take this opportunity to remind you all to like and subscribe to this channel, so we can continue to have these interesting podcasts with half-decent guests like my good friend Gil. Let's get back to the podcast. He's half-decent. No, he's fully decent. So what I'm trying to ascertain here too is that you've got this program, and but there's not always a requirement for, like, every commercial solar system doesn't require maybe PowerCAD, does it? So what size, or can you, what are the factors that say, yes, I definitely need to use PowerCAD because of this, this, and this?
Right. So it's interesting you say that with regards to size. So if we took a bit of an idea, like, we know that in Queensland and in other sort of areas, you have to get sort of engineering approvals done for over 30 kVA. So that's actually a good place to start, because 30 kVA is roughly 63 amps worth of capacity. So that's generally your domestic and small commercial side of things, which is what most electrical contractors can handle off the bat.
Can I just stop you there for 1 second? Because we know the changes of AS 4777.1 2024 when we're talking about interface protection. In Victoria, except for one distributor, the rest of them have said over 200 kVA in regards to interface protection. But in Queensland, under the Energex Ergon mantle, is that...
It's the same.
It's the same.
Yes.
Yes.
Okay, so, all right, so with the over 30s, you still have to go through checks and balances. With regards to tying into an existing installation, if, the rule of thumb that we use is that if you're doing anything 100 amps or above, so a 50 kVA system, for example, will tie in with a 100 amp supply.
Right.
If you're tying in with 100 amps, that's a fairly substantial supply to put into an electrical installation, because you're generally getting up around that area where you're sort of saying, okay, do I put in a molder case breaker? Do I need to look at fault ratings? Is there something else here that might be a contributing factor, like safety services, for example? Safety services in an existing installation are actually quite critical and need to be taken into consideration as well. So when you talk about your ratings, once you go up to and including 250 amps, it's recommendations to do checks and balances to tie that circuit into an existing installation.
So are we talking a shall or a should here on the standards?
It's a should.
It's a should.
Should.
Okay.
So when you go above 250 amps, so just say that we're doing a 200 kVA system.
Mm-hmm.
So that is roughly about a 400 amp connection. So that's when the shalls start kicking in.
Aha.
Okay, so that's where things like tying in and comparing things using PowerCAD or whatever other means that you might have to do it, of checking your breakers and your trip settings and your time current curves to make sure that you have adequate spacing according to ASNZS ASNZS 3000 clause 2.5.7. Reliability of supply. Now that's a massive sort of section to go through, but jumping back very quickly, this is where the engineers or the users or the people doing the work have to get those checks and balances done, because protection with automatic disconnection of supply is critical in some applications, and it's all about being able to safely isolate the faulty part of an electrical installation while keeping the lights on with the rest of it.
Right. So we're talking about with PowerCAD, it has the ability to draw from a huge library of up-to-date products in regards to breakers, and also to work out the relationships between the existing circuit protection and the additional circuit protection that may come in, and spit out a report, for want of a better word.
Mm-hmm.
And so it sounds it's quite in depth.
Yes. Yeah, and that's actually like a minimum sort of standards requirement,
right,
out of ASNZS 3000. And it's not so much what the supply authorities tell you to do, even though it says it in some of their standards that you have to do checks and balances for fault protection and other checks according to ASNZS 3000. So where you're tying that in is, which we'll probably end up talking about soon anyway, is that compliance, safety compliance, and will it do the job? So that's where it'll sort of come in, and this is where myself as an engineer in Queensland, RPEQ, this is where it sort of comes in more for me to make sure that I'm doing those checks and balances and saying, yes, it's okay, sign off, tick in the box, give that to the customer, the solar installer or the solar company, to make sure everything's good.
So does Adrian, he's no longer, he sold the business, is he still conducting the PowerCAD training?
No.
So
it's all me.
So it's all you now?
Yeah. So where was I? I was in Perth the other week, and I did 2 days in Perth, and the second day was my 46th training day since September in 2021.
Wow, and you go to New Zealand as well?
Yep. So the training gets done Brisbane, Sydney, Melbourne, Adelaide, Perth, and Auckland. And now we're sort of in talks with a few other places where companies say, hey, look, we can't fly 15 people to you. Can you come out and do the training with us?
Right.
So there's some interesting locations being brought up with regards to that.
Oh, very cool. So are you talking about Pacific Islands that have the same 400-volt nominal voltage as okay, and abide by the same standards, either as a shall or a should, because I'm not sure what goes on in, Samoa, Fiji, Papua New Guinea.
That's right.
Right. That's really interesting.
So yeah, and
'Cause I know you like talking.
oh, maybe.
Look, I'm saying this because I've known you for a very long
know.
time, and you've always helped me out with the training, and I want to talk about that. So this PowerCAD, you were knighted by Adrian. Adrian has left. He hasn't abdicated. He's just left, and you're left with the crown, the PowerCAD crown. Are you going to? Are you looking? Are you looking for anyone else to assist you with this at this point in time, or is it manageable with?
Well, with the training side of things, it's manageable because we plan the training months in advance. We know where we're going to be.
Right.
We do through the existing people at PowerCAD. Susanna helps us out quite a lot. She's amazing with regards to the planning of the courses and structuring all that sort of stuff. And so we'll coordinate and try and work out where's going to be good for training and what times. And then we'll start booking it in tentatively, and then do mail outs and try and get people on board and all that sort of stuff. And it's fantastic. It really does work out that way. For example, Perth, we had 1 day secure, and we had a few people maybe for a second day. And Susanna was able to sort of go out and contact a few people, and we ended up getting enough people in to do the second day. So,
wow. Sorry, go ahead.
I was just going to say, and it's interesting though, is that people, they don't really sort of, I suppose, understand what they're getting when they do the PowerCAD training. When we do our solar training, there's a lot of detail in there, and the amount of people that walk out going, wow, I just got absolutely blasted by so much information.
Yep.
And I know so much more now. That's the similar sort of thing that they get with the PowerCAD training, not only to use the software, but I started quoting some stuff with regards to the standards. They get that kind of information as well too, because it's all got to relate back somewhere.
It's really interesting. I mean, obviously we're involved in an industry, and any industry requires continuous professional development. That obviously I'm leading up to the fact that we are going to be conducting some training in Queensland very soon at the start of September.
Yes.
Commercial solar design install, and we're looking at a 1 megawatt system. I'm going to be dealing with the DC side, but can you maybe for the listeners go through some of not only what you're going to cover on the day, but some of those classic mistakes or issues that you see from a design perspective? And let me clarify this. In Queensland, the engineer plays a heck of a lot larger role in the overall design of these systems than say down in Vic.
Well, it's interesting you say that. Firstly, not only am I an RPEQ, but I'm also now an RPEV. So
please explain those.
Okay. So Victoria now has the registered professional engineers side of legislation and registration.
Right.
So Victoria has taken on the model that Queensland have, and through mutual recognition, I was able to get recognition through RPEV. So through Victoria. The other states are looking at it as well too. But not only am I RPEQ, but I'm also a chartered professional engineer, like chartered status. I'm on the National Engineers Register, and a few other sort of things after the name type thing. And that's generally where the other states have it. So me being the RPEQ in Queensland, now there is a legal requirement that anything needing to be done which requires assessment, complex calculations, or relation to standards that where they are not prescriptive, you are required to get a registered professional engineer at Queensland involved.
Yes.
And it's not just electrical, it's civil, structural, all this other. It's across the board.
That. Yeah, right.
Well and truly across the board. And so you are, that is law. And unfortunately, a few people don't realise that, so they get caught out. But the main thing is, though, is that the process that Energex and Ergon, Energy Queensland, stipulate is that you must engage an RPEQ if you're going above 30 kVA.
Right.
So this is where I get brought in and help out with the design aspects of it. And it's, we talked very quickly about the interface protection relay.
Yes.
Now it's over 200 kVA.
Yes.
That's just one element of many that we actually have to go through to make sure that we achieve, our safety compliance will do the job.
Interesting. So from a training perspective, what are the participants going to?
Yep.
What from your perspective? What are they going to? Sorry, I'll restate that. What are you going to talk about on the
What
day?
am I going to talk about on the day?
Yeah.
Yes. Okay. So primarily, we'll start off with the Australian standards and how it relates to what they are doing. And we're talking about people, and we've had this before. People who have come along, they have done sort of, a few 30 kVAs, they might have done the odd 100, but under supervision of someone else, like, getting the information, putting it together and then going, okay, that's how you do it. So we're going to talk about the standards and the information with regards to what it all relates to and how it all sort of pulls together to make it that we have a good design for larger systems. Then we're going to talk about some information on manufacturers and equipment and how they relate to the Australian standards. Then we're going to talk about the Energex standards, Energex Ergon standards, and then we're going to talk about the Energex Ergon process. So not only are we going to talk about nuts and bolts of what cables you use, circuit breakers, that sort of thing, and what standards they all relate to. We're also going to talk about the actual process for lodging a larger application through Energex or Ergon to get us through in one piece, because the time involved, that's the true thing.
That's the thing, isn't it?
Yeah. We need to make sure that we're navigating that process so we don't have to sort of do any loop backs or anything like that, because that just costs us more time. And so we'll be talking all about that and trying to get them a more of a feel for how we actually go through the process, because it's not scary. It's just got several toll gates in there that we need to negotiate. And so if we can make it through, with everything in the right place, then that matches up with all the ticks in the boxes that we have to do with Energex and Ergon doing their assessments, and it just goes.
Have you? So from your experience, what are some of the classic? I'll use the word issues because I can't think of a better one. That, from a design perspective, that you see some of these systems that might be a half a meg, and you go, you got the cabling between the MSB, you got the cable between the MSB and the interface protection wrong. You got cable tray against the wall when it should be off. You haven't allowed for derating.
Yeah.
Are these some of the things?
Yeah,
that,
spot on.
Yeah.
It's interesting is that interpretations of the standards. We talk about what we think the actual text says, but when you sort of have a look at it from an application note side of things, and for example, the cables, we've got AS/NZS 3088.1.1 for Australian conditions. If you read, not only have a look at the tables, if you read all the information in there, all the application notes in 3008, and then have a look in Appendix A with some of the examples, there's a lot of information there that you can glean to make sure that you're doing all those things correctly. And it's amazing that a lot of people don't realise that, as you pointed out, a change in installation conditions changes the rating of a cable.
Totally.
Yes. And so I'd probably say that the most common thing, especially for like your 500 kVA systems, you're talking about 1,000 amp connection into an existing installation.
Yep.
How you do that has to have a lot of thought behind it, because there were changes with the switchboard standards, over the last few years. We're now with 61439.
Yep.
Even though technically 3439 hasn't been taken out of
right.
AS/NZS 3000,
right?
It is still there, but how switchboard builders and designers use those is completely up to them. They will, and the supply authorities. It's quite interesting. The supply authorities, they have different thoughts behind them, where they're generally saying 61439 is the standard, and that is how we want things to be done. So you might have a board that's 10, 15 years old, done under 3439, and you're wanting to do things now with current standards, and it's just it doesn't match up.
And so you have to bring the existing up to the current, really?
Or to a degree, yes. Or you have to somehow introduce a connection into that switchboard that might be an additional tier to an existing board where the facility is there to connect it in, that the new section complies with 61439, and the switchboard builder gives their blessing and does all their checks and balances. I said, yep, everything is good. We're good to go here.
And again, like, I'm really looking forward to this event because I can actually sit back sort of in the afternoon and listen to you and heckle if required. But I never know.
Anyway.
I always learn a heap. I did get one question at the last Melbourne training, and it was a really good one, and I didn't have an answer for it. When you put cable tray for AC off the wall, as opposed to cable tray or cable ladder attached flat to the wall,
Yes.
off the wall, it derates less because of this airflow.
Correct.
Now, the question that was asked, what distance does it have to be off the wall to qualify to fall down, to actually incur less derating? And I went, I don't know. And my next thought was, I'm going to ask Gil.
It's interesting. Okay, so if we take...
Can you explain a little bit in more detail, better than I did to the listeners, what I'm actually
Sure.
talking about? Yeah.
Okay, so take it back to the grassroots of cable ratings. Cable ratings are to do with a start temperature, a finish temperature, and the finish temperature is usually the cable rating. So PVC 75, PVC 90, it's 75 degrees maximum operating temperature. XLP 90, that's 90 degrees, and then we have our other ones which might have
110, yeah.
110 or 125s and that sort of stuff as well too. So what you've got is essentially you've got a margin of operating temperature between a theoretical start, which is taken in Australia to be 40 degrees, 30 degrees in New Zealand, and you have current that you're putting through there, and obviously you have resistance in the cables, I2R losses, temperature comes up, and the closer that you get to your maximum operating temperature is the closer that you're getting to your final rating of that cable. So break it down. Cable ratings is essentially about heat dissipation.
Yes.
So
the insulation's ability to dissipate the heat, not the conductor.
So when you have that cable rating that you're trying to achieve, if you do things like put it on a surface, restrict the airflow around it, put it in conduit, partially surrounded by thermal insulation, put it underground, those sorts of things, that has a tendency to restrict the amount of heat transfer from the cable to the surrounding environment.
Right.
Hence, that operating temperature climbs quicker when you're putting in less current.
Right.
And so it's quite interesting is that when I do the throwback to the PowerCAD training, we talk about where you can actually gauge the operating temperature within PowerCAD. Now, that's a critical factor that I point out to everyone, is that if you're getting close to that operating temperature, it might be 90 degrees for XLPE, do you actually want that cable running at 85 degrees just to achieve that rating?
Right.
And because that 85 degrees is heat, and it's wasted heat.
Yes.
And you put that into terms that wasted heat, the client is going to be paying for that at the meter at the front gate. If you're doing a solar system and you've got a cable run coming from the inverter out to your distribution system that's going to be losing a lot of that heat, that's lost production that you're getting from the solar side of things. It's an inefficiency. It's a loss. So what you're trying to do is trying to minimize that, and especially like in an environment where you might have HVAC, air conditioning, is that you're actually paying for it twice, because you're paying for the heat and then you're paying for the HVAC
right.
to pull the heat out of the building.
That's a good point.
So what you're doing is that spacing that cable tray off the wall.
How much off the wall though, Gil? Sorry.
Okay, so there is a clause in 3008, and if I remember correctly, I'm hoping it's right because I know it has changed between versions, 1.5.5, and it is cables installed in air and restrictions on airflow.
Right.
So if you can show that a cable installed on like something has not had its airflow, surrounding airflow restricted by more than 10%, then it can be classified as being installed in air.
How do you work out this 10% rule when it's in tray slightly off a wall?
Okay, so what you're doing is that you're looking at, for example, if you look at cable ladder, let's talk about cable ladder as opposed to tray.
More airflow in cable ladder, obviously.
That's right.
Yep.
With the rungs on the ladder and keep it away from the edges and that sort of stuff.
Yes.
That's already been looked at with the spacings of those rungs to say that there is theoretically no more than 10% restriction of airflow around the cable, because essentially it's sitting in air except for the little bits with the rungs.
Unless that cable ladder is affixed straight to the wall with a lid, then it simply becomes like cable ladder.
Enclosed.
It becomes enclosed.
That's right.
But once it comes off even a little bit, right.
So when you're looking at cable tray by definition is more restrictive on airflow than ladder. So therefore it's, and if you have a look at the spacings and the gaps and that sort of stuff, it's actually more than 10% restriction on airflow. So,
but in the standards, they don't make any distinction between ladder and tray, though.
They do. In 3008, they do.
Edit. No, I'm joking. Wow.
There is, and it's hard. Like as I said before, it's all about interpretation. But within 3008, there are some diagrams and some information in there that talks about that if you are doing it on perforated tray, it's supposed to be selected as being installed on a surface.
Right.
And so this is where we sort of, it's that bit of a grey area.
Okay, so there is a grey area. Gotcha.
There is a little bit of a grey area there. And it is difficult. It's only because I've spent time reading these things that I sort of come across it and I find these things and then just sort of put that to, in the memory bank and go, okay, I'll bring that out when I need to. And so spacing it off the wall, the rule of thumb is that, you I think it's, and I think there's diagrams in there, if I remember correctly, it's figure 1A, 1B. Figure 1A is multi-cores, I think figure 1A is single phase, figure 1B is three phase. There's diagrams in there that show you how to install cables to not attract deratings. And so it all talks about one cable diameter spacing, two cable diameter spacings, that sort of stuff. So if you have a look at figure 1B, then you should get more of a feel for how much spacing off the wall you need to do to try and get that cable rating a little bit better.
And this is some of the things we'll be talking about.
Yeah.
While you'll be talking about, I'll be contributing where I can because I'll be doing all the nitty gritty DC and cable tray selection for the DC cable. It's because like the more I look at AS3008, now I know a lot of people who are listening now who are designers, they're using JCalc, but my hat off to whoever invented JCalc, amazing. But I think it's really important to actually understand where JCalc comes from, and also just there are these grey areas inside the standards. And I'll give you an example. Bunched on a surface, DC cable in cable tray on the roof, right? Mm-hmm. After 20 circuits, the derating finishes. At 20, it's 0.38.
Yep.
And after that, it's like, it ain't even there.
Yeah.
So my question is, if I put in 21, 22, 23 circuits, do I still apply the 0.38 or do I apply something that is not there?
Okay, two parts to this.
I love it. Yeah.
And the two parts depend on the ratings versus the current going through each cable. So if you have, say, a cable which is loaded, then that is obviously going to, we talked about operating temperatures. Yes. It's going to heat up. It's going to be a contributing factor to heat surrounding heat with surrounding cables and that sort of stuff. That's where we need to take that into consideration. However, in AS/NZS 3008, there's the 35% rule. So and you can find that in there in a couple of different places.
Okay.
So, for example, if you have a cable which installed by itself in normal conditions is rated for, say, what's a standard string cable rated for? About,
let's say 6 mil, it might be 67 amps, something like that.
67 amps.
I think so,
right.
yeah.
So how much current do you actually put down that cable?
With some of the bigger panels, let's say that you do push the ISC on some of the bigger panels, maybe 14 amps.
14 amps.
Unparalleled.
Unparalleled. Okay, so if we're talking about 14 amps with a cable rating of approximately 67, so let's just say 15 amps and 60 just for round numbers here. So that is actually 25% loaded. So that technically is less than the 35% rule.
Yep.
Therefore, you don't actually have to worry about deratings.
Hang on a sec. Hang on a sec. You say you don't apply the 0.38 rule?
To a degree. Obviously, it has to be assessed, has to be looked at. I'm not saying it's a blanket rule that just applies everywhere. Has to obviously go through an assessment process. But for example, if we're talking about, say, in a building, we've got lighting circuits going up through, sitting on some tray or whatever else that's there, and they're all together, and those lighting circuits are rated for 16 amps, and we're putting in some LEDs, might be a couple of amps each. Then they don't have to be. You don't have to worry about them with any sort of contributing heat to the other circuits. So 35% rule kicks in. We don't actually have to worry about applying any deratings to them.
But if you're talking about DC cable bunched in a tray, and I'm talking about if it's not cable tied nice and neatly, and there's a question there I'm going to ask, that if you open up the tray, the cable spills out like the entrails on a samurai movie, right? You know what I mean? There is... And the reason I say this is this, because I was trying to establish during the training that the best approach financially and that intrinsic relationship between am I running single strings unparalleled and their relationship to how many other strings are in that same cable tray, which relates to the size of the cable tray, it's set, and all those relationships, because it's very important.
That's right.
And I basically came up with... and I'll jump in here. What we tend to do on our commercial jobs, we don't parallel any strings at all, and we use string fusing at the inverter, so we can get away with the, say, 110 kVA sun-grown, not using a 25 mil earth
for all the arrays
unless
and
there's
and stuff.
unless, and this is roof mount, unless there's some lightning protection, which changes everything anyway from an earthing perspective, because 25 mil earth is very expensive on a 1 megawatt system, and then, of course, there's other aspects about if you parallel, you need wire connectors and all that labour. It's trying to work out that nitty-gritty.
That optimum
that optimum point.
Yes.
So I assume straight away that if you're putting like slightly over 20 circuits, 20 runs of pos and neg, 6 mil, which is 67 amps, and you're going over 20 times 0.38, you're well okay. But the question is, if I put 25 in, what happens then? Is this where that 35% rule kicks in?
Well, you'd probably be looking at the 35% rule first. So you'd be having a look at that and going, okay, how much do I need to apply to this? But then if I look at the 20 and I realise that having 20 circuits around, I mean, physically, one cable with another 19 around, it's obviously going to be fairly tricky to facilitate.
In a 150 mil tray.
And, you are sort of looking at that going, okay, let's have a look at, it being practical. And can you actually space these out a little bit? As you said before, we're not talking about like, entrails with samurai movies and all that sort of stuff. Yeah. But we're talking about,
well, you can stack them, but then again, you're restricted by the height of the height of the cable tray.
That's right. And all you're trying to do is just trying to maximize as much airflow as possible.
Correct.
So, flat lid, peak lid, that will make a bit of a difference, obviously.
We've had this conversation before.
We have. I know, a few times.
Yeah.
So I guess it comes down to just doing the assessment on it. And look, at the end of the day, if you're ever unsure, then use a job that you're doing during your testing and commissioning to go and actually do some other testing on there. Like let the system run for a few hours during the middle of the day, lift a section, get a thermal camera and have a look. And so this is, something that we're doing with, some of the works especially, that, connections and switchboards and stuff like that, is that if you are unsure, and if the switchboard builder might be a little bit iffy about things, go, okay, how about we actually do a before and after thermal camera assessment?
Yep.
That it might just come down to a little bit of extra testing that we need to do in testing phase that will satisfy our sort of questions.
Look, that makes perfect sense to me. I want to stick with the DC cabling for a little while longer, because when you're designing these systems, one, the more cable you're using, like if you say, for instance, design a system, it's 4 mil, 6 mil, and 10 mil. Invariably, there may be mistakes made between the 6 mil and the 4 mil at 2 o'clock in the afternoon on a hot day and everyone's tired. Two, there's certain economies of scale where you say, you know something, I'm going to run everything in 6 mil. The longest run is under 2%, way under the recommended 3, definitely under the shell of 5. I don't care if some of the rungs are 20 meters, and I'll still use 6 mil because goddamn, I mean, you know what I mean. I can use the one cable everywhere, and everyone knows, right? And then I try to standardize maybe the tray. I use 150 everywhere or 300 everywhere, because sometimes spending a bit more on material can actually result in a cheaper overall project cost because of the ease and the clarity of the design.
Yes, 100% agree. And the thing is too, is that are you actually paying more for materials if you're sticking with one size?
Well, this is the thing. You've got discounts that you can apply possibly if you're buying just all one size of tray.
Yeah. So take a few steps back on
Please.
that. I did a job many years ago, and it was for an offshore facility, and it was all generator run, and there was HV and a whole heap of things involved. And what they were doing is that they had 11 transformers on site, like kiosks.
Wow.
And so ranging from 1500 kVA, a couple at 750, and then smaller ones, so 315, 250s and that sort of stuff. And so I looked at everything and I talked to them about it, and I said, okay, so you've got this big distribution system. What would it actually be from a design perspective, and with regards to how many different sort of selections that you have of just doing 2 sizes on your transformers? And they went, what do you mean? I said, well, how about we just look at it and say anything up to and including 750 is 750, anything above that is 1500.
Right.
And they went, oh, okay. And I said, how about we go back to the, for example, the kiosk supplier, and say to them, what does that mean for our overall costs, even though we know some of those are going to be slightly bigger. And so they went, okay, just for Pete's sake, we'll just go and do that. Anyway, they came back, small time later, and went, oh my God, you're right. We just saved an absolute fortune because of the fact that we're standardising on our sizes. And not only is the procurement side of things going to be a lot easier, but their design side of things, and because you've got a kiosk supplier that might or might not be supplying the transformers. You've got to go get the transformers from somewhere else. They've got to design a range of different things to suit the different solutions. But you come in and do like more of a rule of thumb, and that actually saves a lot more in the design and the implementation of it too. So there can be savings by using a rule of thumb approach. And, for example, similar sort of projects that I've done, with MCCs, like motor control centers, where we'll have all these different sizes of drives and whatever else. Then we can look at the solution for this and have a look at, say, our feeder circuit breakers and have a look at the adjustability on them, for example. And as long as they're complying with, our coordination by the manufacturers, then we can standardise on a lot of that as well. So, for example, if we're doing distribution supplies that, for example, you might be doing, 160, 200, 250 amps. If you're using a particular type of breaker and it's got that adjustability, then use that one type of breaker.
Yeah, right. That makes sense.
Yeah. And it just cuts down with a lot of that, variability and having to sort of change designs too much as you're going through. And especially if something changes, and don't always just think about it in terms of I'm doing my first pass at the design. What can I do here?
Yep.
Think about it in, most designs, we'll go through 2, 3, 4 iterations.
Yes.
How much extra do you want to do on each of those iterations to get to the final solution? And this is where some of that stuff comes in, because if you're able to, say, have a breaker, for example, that you are supplying 160 amps out of, and it's a 250 frame, and it's got a trip unit on it that goes from, say, 100 to 250 amps. So an electronic breaker, for example.
Yep.
That all it takes, if somebody comes along and says, oh, that circuit now is going to have 190 amps on it.
Right.
It's just turn the dial up, redo the cable calculations, everything okay with the switchboard builder? Yep, cool. But we've already thought about it and said, it's all good.
You made provision for it.
Yeah. So you doing it with the DC cable?
Yeah.
You're standardizing. It means it's one cable. You can buy it on bigger drums because it's cheaper.
That's right.
You can, all your fittings, that side of things.
Correct.
It's all the same.
That's right.
There's no potential for you accidentally getting the wrong, the crimp or the wrong connection in some place between 4, 6 or 10 or whatever else it's there. And you know that not only are you streamlining things, but you're actually removing potential points of risk with
Absolutely.
the installation going wrong.
Yeah, and it's a really good point. I mean, the couple of things you mentioned, like for instance, if you are using 10 mil on MC4s, you need a special insert with your crimper, right? And all the other stuff, and even going back to like paralleling strings, there's more potential points of of points of failure, because the more joins you do, the more chances, and just the chances remain the same, but there's more joints, so the actual number of potential issues increases. There's not a percentage thing because the percentage stays the same.
Yeah.
But it also carries on from a cost-saving perspective, that the less time you spend on a roof, if your installation times come down, better OH&S, less time for the EWP to be on site, less time for the site shared, site toilet, and all those other things.
Keeps going and it keeps going.
And that's
right.
why I think you really have to spend the time designing both the AC and the DC side and go, what about this? What are the pros and cons? And make some kind of decision matrix to go tick, tick, tick. Because it seems like, parallel the strings. Yeah. Oh, well, hang on. Why? Oh, because there's less. Well, hang on. Fault finding. You got this. You got that. By the way, you've suddenly doubled up the current the cable has to take, and maybe with a radical derating, you can't use that cable. On that note, and these are the kind of things we discuss with the training.
That's it, and a lot of that stuff goes into that. The rule of thumb.
Yep.
And this is where I'd sort of have a tendency to have a talk about it and use, experience from previous projects and that sort of stuff too. That, if you can just think about it a slightly different way, then it might actually save you. Like, quickly talk about one of the things that in engineering land that I don't agree with is doing the same thing or doing it the same way that I've always done before.
Right, because that's the way it's done type thing.
Yeah. This is the way we've always done it.
Yes.
No. And it's interesting. A good colleague and mentor of mine, Nick, he's a very senior engineer, extremely knowledgeable, and his favourite saying is, "I don't subscribe to the grandmother principle."
Right.
Because just because my grandmother did it a certain way doesn't mean I will.
Yeah.
If you can sit down and do that critical analysis that you talked about, you might end up saving yourself a lot of time, a lot of money, a lot of hassle. And we all know that rework is the ultimate killer of jobs.
Yes.
And so we're trying to front-end load these jobs as best as we can so we don't have those sorts of issues coming up. As you said, if we do everything, before we even go to site, if we do these critical analysis and do it from a perspective that, okay, this is how we've done the last few jobs and it's worked, will this still work for this particular job? And it might only need to be a little bit of time that we spend on doing that analysis.
Yep.
Will that actually save us a bit more here? It's all about, we all talk about it, learnings from previous jobs and stuff like that. But if you're not truly looking at it, then you just, you are predisposed to make the same mistakes over and over again.
Absolutely. I mean, we just have to, walking away from solar a bit, we just have to look at history repeating itself. And we want another podcast.
Yeah, exactly.
I want to get back to AC cable and cable tray because it is it can be potentially a massive cost, especially when the runs, for whatever reason, the switch room where you can actually put components, the whole bit can be fairly far away from each other. Now, if you put a neutral next to, say, a trefoil configuration, right? Does because the neutral's just, there's no real energy going down. I mean,
in theory, okay, yep.
Can it act as a heat absorber from the heat being dissipated from the installation from one of the actives that it's next to? And if that's the case, why wouldn't you always have a quadfoil config to take up less lateral space in a tray with only a slight increase in vertical space? Please explain.
Please explain. Okay, I'll do my best.
Yes.
And I know that there's a lot of debate about this out in industry.
Right.
So my take on this is that I am trying to keep the airflow restrictions to a minimum. So if it means that I've got my 4 cables together, which are already sitting in a footprint, either in trefoil or quadfoil, or,
yes,
however they are,
yes,
and that I can space them a bit further away from the next set.
Yep.
That means that I'm helping to maximise that airflow. So that neutral conductor element may not actually be so much of an influence. So, and as well too, is that
don't forget the earth though. If we're talking about inverters running to the interface protection, we're including an individual earth.
So if you have that earth stacked on top as well too, yes,
right, okay. Can do,
right. As opposed to having them stacked on one side of the tray, which is restricting, how far apart you can put your other sets. Then that sort of all needs to play in together.
Wow.
So there's my opinion is that I would rather see a set of cables sitting there, tied together as much as possible.
Yes.
For a couple of different reasons, and trying to maximise the airflow around it for cable ratings. You've also got other things as well too. In the event of a fault, what actually happens to those cables? And this is where you talk about cables being tied together and making sure that they're secured properly and all this other stuff as well too.
Right.
And then you're talking about if you have a look, where is it? In 3008, I think it's Appendix D, there's a guide as to how you do your orientation of your active conductors. Oh,
yes. I've got that in one of the trainings, from a magnetic disturbance perspective. Yes.
So that not only applies for that, but also to that you're trying to, minimise your losses. I mean, that's where a lot of it comes from.
Yes.
If you can keep everything nice and balanced, you are actually minimising your other losses.
Yeah, right.
So we talked about, I squared R losses with regards to cables before. Now we're talking about other potential ones, which is more to do with reactance.
Right.
And so this is where trying to keep them together, and as you quite rightly said, theoretically no current in the neutral. There probably is.
Okay.
So, and that, is going to be...
But it's a balanced load. It shouldn't be. The inverters are a balanced load.
In theory, yes.
Aha.
So you may actually have some scenarios. I mean, that in theory, everything is nicely balanced.
La.
Yeah, exactly.
Sorry.
And this goes back to the old trade days where we had to do the vector diagrams, the power factor vector diagrams, all this other stuff as well. Yeah, phasor diagrams, all that sort of thing, where we had to do it with the ruler method and everything too. That what you're ideally trying to do is get zero result out of the current flowing through a set of conductors. So by doing that and keeping them all together, you're doing as best as you can with regards to that. So no stray currents or anything like that. Interesting point though is that if you are actually, this goes back to the cable operating temperature thing as well, if you are grouping your cables that way,
yes,
and your earth cable is sitting as part of your group,
yes,
your factors with regards to how much prospective fault current that earth cable can take starts going down, the warmer the earth cable is. So there's other things as well too. There's a table in the back of 3008 that talks about your insulation factors based on your not only your maximum operating temperature but your actual starting temperatures and all this other stuff as well too. So there's a few different things that play into it. That's why I keep talking about coordination reports because they take all that into consideration. So yeah.
Very interesting.
Yeah.
We're still talking cable tray and AC cable again because it's such an expensive component. Like from
and it can be a huge factor on a job as well too. I mean, have a look at the price of cabling these days, and I suppose another thing too is that have a look at your method of installation. We touched on doing the stuff on the roof.
Yep.
Have a look at doing the stuff on the switchboard. So, if you've got a scenario where you're having to potentially deal with, what we said before, 500 kVA system, 1,000 amps. 1,000 amps is not exactly easy to cable. You've got to get it right.
Yep. It's I mean, what's your rule? Is there a rule of thumb that you would apply? For instance, say, for example, that you've got an example. I'll give you an example. In the training, I use from between the PVDB, the interface protection, the grid safe.
Fantastic product.
Thank you. Tick tick.
Yep.
1,800 amps, right? So you're talking a big. In the end. It's parallel 185s, right? So 185 mil paralleled XLPE 110, right? Now, obviously, you could go a larger cable. You could go a single cable if it was close, right? So three 185s, Gil, whatever it is, okay, it's whatever it is. So let's say that it's another cable size and you decide to parallel. What's your view of going, well, if I can achieve the same current capacity and V rise from a single cable compared to parallel, what's your view from an installation perspective? Because to me, logically, multiple smaller cables are easier to handle. Is that so? What's your view?
A few different factors. The length of the run probably being the biggest factor.
Right.
And I've heard of horror stories before as well where they've had to run it through installations and they've got this suspended cable, ladder, tray, whatever, through the middle of the building on rod and supports and all this other stuff as well. And they don't factor in that to run that cable, it might be 150 metres or something like that from one end of the shed to the other, the weight, and the fact that to run that cable in, because there might be a couple of dog legs or whatever else that's there, that you need a crew of, say, about 8 to 10 people on scissor lifts or boom lifts, pulling that cable through at different stages and all that sort of thing as well too. So do you want to do that multiple times or do you just want to do that once with a larger cable? So this is where this sort of analysis starts coming into it. A rule of thumb that I've got with some of the clients that I work with that use flexible cables, for example.
Of course.
If you're using flexible cables...
Slightly less CCC.
Probably negligible. It doesn't really sort of matter too much. Yeah. But at the end of the day, things like bend radius comes down.
Yes.
Ease of them to manoeuvre, either below a switchboard or coming into a switchboard or onto a termination within a switchboard, those sorts of things as well.
Yep.
What we're talking about is installation of those cables. You might, for example, you might have to pay a little bit more for a particular cable, but you're saving that 2 or 3 times on the difference between the cables with your installation.
I suppose there's another thing to think of. If, say, you use, let's say, multi on from the inverter to the PVDB, but we don't. We tend to use SDI, right?
Yep.
And I was just thinking, well, you could use multi, but the thing is, multi suddenly has a vertical height of whatever it is when you're using 95 mil.
Because of the bend radius.
I'm saying the actual, if they're all bundled together, it might, and you have to put lid on top, it might go over the edge of the tray. I mean, theoretically, wouldn't it? So
peak lid or whatever else that's there as well too.
Okay, right. So there's a lot to think about.
Yes. Yeah, and as we said before, just because it was done a certain way previously doesn't mean we should do it this way. You know, there could be different ways to run these cables, or there could be different ways to specify them. You know, you might have a cubicle, like you're saying, you might have a 1,000 amp cubicle to come into.
Yeah.
But the switchboard builder assumed that they would be 2 by cables per phase,
Right.
and so they've only allowed for a gland plate to bring in those 2 cables per phase.
Right.
So this is why it's very important to try and coordinate everything, coordination study, and make sure that everything is coming together, because there's no point in bringing together a cable solution into a switchboard which hasn't been allowed for. So there's a lot of things each way on this.
I think there's a couple of things that most people don't make this mistake, but I do make it on purpose during the training. Is I start doing the current capacity and the volt rise calculations from the inverters that way, and I do it on purpose because what I end up with is over 2%, and I go, I made a mistake. But now I have to go back and change that 3 by 185 mil to 240, not because the 185 couldn't do the current.
Yes.
It was because of bloody V rise.
Yes.
And it's just, I know it's a simple thing, but start from that point of supply, point of attachment. You don't want to change that cable. So you're going to do that one. And then if it's like a simple to the MSB and then to the interface protection back to the inverters, sometimes it's different. Then you can sort of adjust where you can, hopefully in the cheapest possible way. Because cable's really expensive. Really expensive.
It is. And then your installation costs can only go from there.
Absolutely.
Yeah. And
Can we talk about... We're going to talk about a lot more stuff, but I'd like to talk about your company and why you started. I always ask this question, why people started their company, when did it start, and a basic rundown of who you are, what you do, and how you do it, and why.
And why.
And why.
Oh, okay. So many years ago, I left school. My dad was just starting off his electrical company on North Stradbroke Island, and he'd moved across. So we'd spent many years over there holidaying and everything. There's history with my mum being over there. My mum's father, my grandfather, he was the chief electrician for the mines over at Straddy, so there's big family history over there. So he started that in the early 90s, just as I was finishing high school. And I got out, I was looking at doing a couple of different things, and he said, look, you've got 3 months until you start uni. How about you just do 3 months with me? It's basically an apprenticeship probationary period anyway. See whether or not you like it. I went, okay, cool. So I started working with him and, being an apprentice. And so did that, enjoyed it. I went, okay, I can live with this. And so uni sort of fell by the wayside, and I did my apprenticeship with Dad. And he's awesome. He's an excellent teacher. He's, his career, he's spent many years doing a lot of big projects, a lot of different things, travel all over the country, spent some time over in Canada, all this other stuff as well too. And we moved around a lot as a kid because of him doing different jobs. The amount of knowledge that he had was, really good. So we, started off wiring houses, and we'd had all these other jobs that would come up on the island and occasionally on the mainland, where it might be something like a set of shops, or it might be a fuel depot or something like that, and he would just know exactly what to do, and he would show me and teach me and make sure that I was doing everything right. And so I got a lot of my work ethic from him, and as well my mum. They're very hardworking people, fantastic, and so I would learn so much from him. And then when I got through my apprenticeship, there was a few different things that I was doing during that time. We were I'd finished my apprenticeship and I was out working, and I was in the construction industry at that point. Moved away from Dad's business, doing a few different things, and I was moving from, say, job to job. And we sort of sat down one time. My now wife, girlfriend back there, close partner. Shout out Amanda. Excellent. That we sat down and we were sort of talking about the future and everything else, and this is the only time she's ever admitted it, but she said,
Here we go.
here we go. You've got brains, you should use them.
Wow. Did you record that? You should have recorded it.
I know. Well, this is back in the day before phones and
yeah,
stuff.
gotcha. Yeah, of course.
Yeah, so, and she said to me, look, Dad's done amazing. He's done really well. But, do you really want to be crawling through roofs when you're 60? And I sort of thought about that and went, okay, all right. So I signed up and did engineering. Inquired, had a look at it. Yep, okay, let's do electrical engineering. So signed up for it at QUT Gardens Point in Brisbane. Went in as a mid-year entry. And it was really good, actually, because, met up with other... and because I'd done the apprenticeship first, I was classified as a mature age student, even though I was only still...
Wow.
Yeah, I was only 21.
Wow.
And so, we were there for the right reasons, and so we sort of stuck together and worked hard. And because I was mid-year entry, they said to me, you can do the accelerated program, which is get your degree done in 3.5 years. So you graduate at the end of a year, or you can do 4.5 years. There's no 4 years once you do mid-year. So I said, okay, I'm going to do 3.5 because I want to get it done as quick as possible. Got that done. Did the degree, did some fantastic stuff as well while I was there, because obviously I've been doing the apprenticeship first, and wanted to gravitate towards more industrial, industry-based learnings. So there were a couple of design.
Why?
Oh,
Just because you wanted to get away from the domestic side of things?
well, no.
What?
When I say industry, that you can do, for example, you can do university subjects where you're doing projects and pracs and whatever else that's there that's focusing on sort of research elements for things that are happening at the university, or you can do industry-based design projects or final year thesis. And so I signed up with a program at uni which puts students out into industry, and you do 6 months worth of industry-based, a project, industry-based project. And so I did mine with Energex.
Wow.
And it was really cool as well too, that they had, going into the nuts and bolts of it very quickly, they had this guy who was an absolute whiz with C, like the programming language C.
Yep.
And he wrote the software for the substation control side of things.
Wow.
And this is back in the day, many years ago. And so they had it all documented there, but they didn't have a lot of the information with regards to what all the different modules did and how it all sort of worked together. And so what they wanted was that they wanted me to put together a specification as to say, if we were going to industry to say we need this programmed, how would we do that? And so I put together all the documentation out of the raw code with no comments or anything like that as to how this software works. And because I'd had the industry experience, I was able to then relate that to how it worked with the substations, the tap changes, the capacitor banks, all this other stuff as well too. It was really cool. And so I got out of uni. I got headhunted by a couple of companies, and eventually I found that as part of that final year thesis, this is why I'm sort of talking about it, is that one of the people that was the facilitators knew someone at the brewery, at Carlton United Breweries at Yatala, who was potentially looking for an electrical engineering graduate. And so I was like, oh yeah, because we'd heard about the breweries in trade college. They were like, with PLCs and control systems, all this other stuff as well. That's where you wanted to go and work if you wanted to go and do that stuff. And so I thought, oh yeah, I'd said to them, okay, I'm definitely keen to do this. And I went, cool. So, their people talked to other people and stuff like that and got it all sorted out. Ended up going for a couple of interviews down there and got the job.
Excellent.
Yeah, it was really good. Had amazing people down there to work with. I still catch up with them every once in a while. I still go back and do a little bit of work there every once in a while with consulting and that sort of stuff. And so I did 5 years with the breweries. Spent 2 down here in Abbotsford, and fantastic experience. working in that environment, because it wasn't just packaging lines and bottling and all that sort of stuff. We did all the site services as well. Plus, I did all the some of the supervisory systems, the databases and data management and all this sort of stuff coming out of the control systems into what they call, I think it was the MES layer, where they had all these other systems that would interface into it and pick data out that they needed to for planning and production, all this other thing. It was really cool. I learned so much during that time. Then I decided, need a change, got to go out and do something different. And an opportunity came up to go out into the power stations. And I sort of interviewed for that, and they said, well, we don't really kind of want you because of the fact that you've got no power station experience. I said, well, how do I get the experience if I can't come and do it?
Classic.
Yeah, exactly.
Yeah.
So ended up doing that, did really well, had fun. Stayed in the sort of the power industry for a little bit longer. Worked at a small biomass power station.
Wow, that's interesting.
Yeah, Jacob's Well, which is off the back of a sugar mill that's there. Really, really cool. Did a lot of good stuff there. And then had another opportunity come up into the mining side of things. So I've spent some time in the mines. Then after that, another opportunity came up with water. So water treatment side of things. Sort of around the later 2000s, Southeast Queensland was in a big drought, and they had slated to do all these big projects to try and drought-proof us. So Tugun desalination, the Western Corridor recycled water plants and pipeline. And so I managed to get on one of those plants for a while and started doing some work there. And then from there, there was a whole heap of stuff going on with work and potential stuff coming up. And I was working for a company at the time where the guy that I was working for, he had done the same thing. He was working for a big company, decided to go out on his own. And so sort of arcing back to Dad, he worked for many big companies and decided just to go and do something for himself. And so I said, right, I'm at a point now where I want to go and do something for myself. And so in 2008, decided to start up the company, AGR Electrical Engineering. It's actually Amanda and Gil Rhodes.
I was going to ask.
Yes.
I thought it was Gil was in there and the Rhodes was there, but
Yeah.
I was wondering about the A.
Yes.
Yeah.
Everyone says it's agro, but anyway.
Nice.
Yeah,
nice.
no, but it's not. It's Amanda and Gil Rhodes. So, and Amanda has been a big part of the business for many years as well too. She is a business manager, bookkeeper, administration, all that sort of thing. So she does a lot of the back end side of things. I do all the obviously the engineering work, do all the quoting, the invoicing, all that sort of thing too. So we started that in 2008. At the same time, I put in my application to be an RPEQ, which was a fairly simple process back then, and I did it. Got the RPEQ qualification. And
RPEQ.
RPEQ.
Thank you.
Yes. So, and then from there, just the work kept going with different projects that just led from one into the other. That led me on a journey around, the whole country. Been in so many different places. I was involved with the gas fields. I've been out on a lot of renewables. A lot of power generation side of things, big distribution systems, and that it just keeps going. And so that's where, we did that. Done the own business now, 17 and a half years now. Have one guy working for me, Norm. He's an electrician as well, did his degree part-time. Got his qualifications. He's now an RPEQ, chartered engineer, all that sort of stuff too. And he is fantastic. He's a really hard worker, knows his stuff as well too. And we talk and we debate standards between ourselves. And it's really good. And the good thing is that he's a mate. I've known him now since 2003.
Wow. Oh, that's a long time.
Yeah, so we've known each other for a while. And I know him, I know his family, I know his extended family, and they're lovely people. Norm's really good, and he enjoys working for me because, we want to do the right thing and follow the right rules and just make sure that we're providing a good solution for our client. and he's primarily taking care of a lot of the solar and renewables projects at the moment, and just he has been now, I think it's 6 years. It really enjoys us working together and doing all of this. He likes the Greenwood products as well too, by the way. So.
We might edit that bit out. No, thank you. No, it's we try. I mean, the reason why we first made the grid safe is because we weren't getting much love from the manufacturers out there that were effectively just engineering companies, and when we had trouble on site with installation and they just said, oh, we just make it, bugger off. Well, they didn't say bugger off, but that's effectively what they meant.
Yeah.
Look, I'd like to ask you a question that I ask everyone who comes along, and it's nature and nurture. Do you think to be a good engineer, is it nature or nurture?
Ooh, very good question. I think it would tend more towards nurture.
Really?
Yes, because a good mentor versus a bad one can make a massive difference.
But surely the brain process is that logical approach that it seems all decent engineers seem to have this approach, and that's why engineers are in such high demand in other areas. Oh, you studied engineering. Oh, we don't. Oh, do this, this, because of that kind of process. Surely that must be. Because I disagree with you. I reckon it's nature, more nature than nurture. But
here's a contributing factor.
Yep.
Okay, so an engineering degree does not teach you how to be an engineer. An engineering degree teaches you to think like an engineer. It's up to you in those years after the degree, and this is why they have graduateships and those sorts of programs within different companies, is that you have to learn the nature of what you are going to be engineering, so then you can apply your your process and your way of thinking that you sort of got reprogrammed with in uni. This is why the engineering degrees are so full on with mathematics, because it's teaching you to have a problem, analyze it, test it, check it, go back if you need to, and really sort of get the gears sort of working in your brain.
Look, I understand that would be beneficial for anyone doing any kind of training, that approach, but surely some people's brains are more adaptable to that kind of. They'd find it easier than other people go, something that goes against my core. I'm going to do it because that's the process. Surely that's the difference between good engineers and ones who would like, whatever.
Well,
I'm pushing my point, aren't I?
You are, and I mean, look, I'm not debating this. So far as what you're saying is that I see a big spectrum as well, and you'll always get that. Doesn't matter what it is. People driving cars, engineers, doctors, tradespeople, that sort of stuff. You will get a spectrum of people who do things different ways, and have a lot of different factors behind them. And there's an old saying in process control terms, is that if you give 10 process control engineers a specification, you'll get 10 different solutions, and 8 of them will work.
Yeah, right. Is that the ratio? Is it? Wow.
It's an old saying.
Okay.
I pick up on a lot of old sayings and things that a lot of stuff that sort of is there. I'll actually do a lot of research on where that stuff came from so I can understand it better, which leads into why I think it's nurture versus nature.
Okay.
Because of the fact that if you're not willing to ask why and where did that come from in the first place, then you're not really doing your job as an engineer. Because I can refer back to the standards, I can have a look at manufacturer data, I can have a look at all this different stuff, and anyone that I've worked with, they will say to me, you have really gotten to the nuts and bolts of this problem, and you're able to tell me, who may not necessarily have a great understanding of it in reasonable terms, why we're going down this particular road.
Yeah, because you've got to the essence of the problem.
That's right.
It's finding the essence as quickly as possible and understanding it. Then you are able to disseminate that information in a palatable, understandable way.
So that's why I think it's probably more nurture, because you have to be willing to do that, and you have to have good mentors who will give you that space to do that as well too. Like, for example, I've worked in a few different places. I've had some amazing engineering managers, and they have given me the space to go and learn, go and do what I need to do, and to find out, and even to stuff up as well too. Because it's, in some cases, it's not about how, as long as you're obviously not doing major damage or anything like that.
Yes.
It is actually good to stuff up every once in a while.
You learn.
You learn. Yeah. Look, I've learned many things from there. From that, including the golden rule of system or process changes and that sort of stuff.
I thought it was read the effing manual.
Yeah, well, that's a core principle as well. But no, you don't make process control changes past a certain time in the day, or even sort of to a degree on a Friday, because if something can go wrong, then you stuffing around with it potentially could do that. So I've had that space within my engineering career, especially in my early days, to be able to go and do that sort of thing. And it's because of the fact that I've had such good, supporting engineers and, other people there who I will go and ask questions. I will be like, okay, so you're saying that it's going to be this, this, and this, but why? Where has that come from? Why do we do it that way? Have we ever thought about, trying to get some improvement in place? And it's funny though, is that a lot of places, they'll be like, oh yeah, if we had our time again, we'd actually do it this way and do all this different stuff.
Interesting.
And I've been brought into a lot of projects too where things have needed a lot of work to get back on the right track. So not only have I experienced that stuff myself with regards to learning and finding out the whys and the whens and the wheres and all that sort of stuff, but I've also seen a lot of how not to do things.
Yeah, very, very important. As a kid, were you the kind of person who was fixing stuff up and wanted to know how stuff worked, or? Yeah, see, that's the thing, and this is where I'll go to the nature side, because every engineer I've spoken to has that same, I want to know how stuff works.
Yes, but I went through, I suppose, a period in my teens where I was clueless, and I'll freely admit this.
As opposed to now. Sorry, mate, I couldn't resist. Sorry.
It's all right. What's the score now? It's 2-1, something like that.
You're going to get me back, I know you are.
Exactly. But the thing was, though, was that I didn't know that, as my wife said, I've got brains. And so because I guess there was stuff happening outside of learning and all that sort of thing as well too, that I was interested in that. It wasn't until I sort of came out of high school and started doing my trade that it was second year college, and I was sitting there and I refer back to the vector diagrams and the phasor diagrams, all that sort of stuff. I don't know what happened, but I was looking at that, and then all of a sudden the mathematics came back to me.
Wow.
And everything just went, oh, right, okay.
A eureka moment.
Yeah.
Wow.
And then after that, everything sort of played out. Everything came together. And it was amazing. That's like nature probably was a contributing factor to that, but it was more of other things that I was learning along the journey.
Right.
And we say it with our kids that they all develop at different speeds and want different things and have their eureka moments at different times.
Comparisons are odious, as they say.
Yeah. So anyway, I guess from my perspective, yes, it is nurture. I did have that inherent need to know how things worked, and I wanted to learn more about things. And I would do a lot of reading and whatever else was there, and I'd be like, oh yeah, cool. But it never sort of clicked properly into place until I was needing to do that as part of furthering myself, my career, future, all that sort of stuff too.
It sounds like mentors too have played a
Huge.
very important role. And I have talked about this with other guests that in this modern day and age, we don't have these rites of passage for a young man. We don't have enough mentors and old people we can talk with. Invariably, our mentors are, oh, I had a great teacher in year 12 English or first year uni or my first job. And it seems to be even more important in this day and age than previously.
Yes.
Yeah. And
well, I'd probably take that as saying that, okay, you've got, with your phone, you've got access to all the data of, for many, many years and information, all this other stuff as well. But you can look at it in that regard. But if you're not having someone there helping you understand it and talk to you about it and help you process that understanding, like, when we talked about it in high school terms, there was content and process. Content was you being able to remember, the times table. Process is being able to work that out if there's something not there where you need to fill in the gap, so to speak.
Yeah.
So, if you don't have a good mentor in that regard, then you might have some of the content, but the process might not necessarily be there. The ability to sort of start from here and get your way over to the end point. There's all. I think there was jokes around like project management and other things like that where you sit there and go, right, start a project, arrow going into a big cloud, going insert stuff here, and then an arrow coming out and going complete.
Yeah. It's all the stuff
cool.
in the middle that's important, isn't
That's right.
it?
Yeah. And so, I mean, I've had some amazing mentors. I've had my dad. I've had engineering managers. I've had other engineers. And through that journey is that not only have I had input from great mentors, but I have been trying to help other people as well too. So I mentor other people.
I know you're involved with the life saving, I want to talk a little bit about that.
Sure.
But before we do, I want to get back to your business because
yes.
you've got your own business that has enough stress. Anyone running a business knows that it's a stressful
I used
situation.
to have hair before I started.
Funny if it was a joke. But not only do you run a business, you run a business with your dearly beloved, which I find amazing. So how do you balance, number one, how do you balance the fact that you are working with your wife and a close friend your wife is an employee, but she's your partner. Your friend's a friend, but he's an employee. How do you balance this and the whole work-life balance and everything? This is like, can you juggle 5 balls at one time? What's?
I can do 3.
You can do 3.
I can actually juggle some. Yeah.
Yes.
I guess this is something that I learnt from Dad. Is that it was father and son. During the day, he was the boss, I was the apprentice.
Right.
Get home of a night time, it's back to father and son. And
it was that clear with him.
Yeah.
That right.
And so we'd have a day where things might not have gone right, could have been words, whatever else it's there. He was, and we'd always talk about it. We'd always, get to the root of it all. And then we'd walk through the front door and that was work day. Here is family day. And so family time, whatever else that's there. And so it's important to, make those distinctions between, yes, outside of work we're, partners or friends or whatever else. During work, this is, how it is. When Norm came to work for me to begin with, we sat down together and we actually talked about the terms of the engagement, not so much from a contractual perspective, but also like how we would do that, because it was a little bit of a thing. And I've heard stories behind people that have done businesses where they have been friends to begin with, and 3 years later, that's it. Don't ever want to see that person again in my life.
Yep.
And I sort of we sat down together and we said, right, this is what it is. We know that we're sort of engaging into this, work-based relationship. At the end of the day, it's my company, it's my house on the line, it's my business.
Yep.
That you are, a very valued employee, but this is how we'll approach it. With everything that has happened over the number of years that he's been, working with me is that I don't see him as being, an employee. I see him as being a colleague, a very experienced colleague that even he chips me on things as well too. And that's what I was aiming for when we first sat down together, is to say, right, we are going to be, partners in this. We're not, going to have that, we're not a big company. We don't have, multiple layers of management or anything like that. And this is what we are going to do. We are going to do good work, and I will be mentoring you. I'll be pushing you, and you're going to be, hopefully doing some good work with me. And, I sort of give back to that with flexibility. Things happen at different times. You might need to go watch the daughter play, some sports or whatever else that's there. And he says, oh, look, Thursday morning I won't be there for the first few hours. I'm like, cool, no worries. Go and do that. And, with that work, and I guess, I suppose everything happening at the moment too with regards to out the back of COVID, working from home, that sort of thing. I know that he does the work.
That's the thing.
I will and truly know that he does the work. And so if he's got any issues, he knows he can come and talk to me about it because he's done that. And so, we have very open and frank discussions about stuff as well too. So not only am I a business owner, I'm the principal engineer, I'm also the HR manager. So and all these other sort of hats that you have to wear, and it's all about knowing that he can come and talk to me about anything at any time.
But the real boss of your business is probably Amanda. I had to throw that. I had to put that in. I had to put that in.
But hey, and at the end of the day, if your business is not operating correctly, if you're not making money, if you're not paying your tax, if you haven't got your insurances sorted out and superannuation, all this other stuff as well, you're actually trading illegally. So you have to have all that stuff in place. And that's where a lot of that comes into it as well too. That, if Amanda comes to me and says, oh, look, Baz is due in a few weeks and this is what we're going to do and da-da-da, I'm like, yep, cool, no worries. And, she talks to the accountant and makes sure that everything is just going along as needed. And it's, while it is definitely a bigger task to run a business, it has got its benefits.
Absolutely.
And, I wouldn't have it any other way. I enjoy it. And I've got opportunities coming up soon which might slightly change that or assist with it. I don't know. But I'm looking at it as potential for growth.
Okay, I'll ask you another question, sort of along the lines of last time. Are business owners nature or nurture? Because if you give me the nurture thing again, I'm really going to... No, I shouldn't say that, because I think there's people who will never go into business.
Yes.
And there's people right from the word go who've gone, no, I want my own business. And most business owners probably fall in between, right? So, yes, nature or nurture?
Ooh, okay. When I started my business, I already knew what I needed to do because I'd seen Dad do it and I had a bit of a handle on it.
He had his own business.
He had his own business.
Nature.
And I would actually have to tend to agree with you because I'd seen him do it and I'd seen other people do it as well. And the good thing was is that I had, Amanda, ironically, not ironically, but additionally, Amanda was actually doing all the bookwork for Dad with his business too.
Oh, wow.
So she already knew how to set a business up. We had an accountant at the time who was able to help us set it all up. And so I sort of jumped into it. I was, out of everybody involved with starting my business, I was the least experienced out of it. So I had no idea what we were jumping into. I just knew that I wanted to do this. And so it took a good 6 months to get everything set up correctly to a point where I could not only do the engineering work, but also do a lot of the other stuff, like, invoicing, quoting. I mean, you guys definitely know it, how much time you spend quoting things. That having all that stuff set up from the start is, a lot of weekends, late nights, trying to formulate it and get it all right.
Yep.
and make sure that it's good, because the next time you send out a quote, that if someone accepts your quote but things change, you need to have all your T's and C's in place and all this other stuff. So all that side of things had to be set up correctly, and it took a little while to get all that stuff done. It's funny is that you say nature versus nurture, people who want to do it, who don't want to do it. I had a lot of people coming to me over the years and asking me, what does it actually take to run a business? And so I'd actually sit down with them for a couple of hours and go through everything, start to finish, of what they needed to do. And I'd probably say out of all the people that I spoke to, less than 50% said, oh, okay, I'm going to start a business still. Once they got that handle on what was involved, a lot of them just went, you know what, I'm happy being an employee or like a contractor or something like that. I'm just going to do that. They were talking about doing a full-on business where, and when I started my business, I said, I don't only want to just do contracting for other companies, whatever else, I want to do my own work. Hence why I did things like buy PowerCAD. I wanted to do my own work. So you get those people that say, hey, I want to start up an engineering firm, I want to have employees, I want to do certain things. Yeah, a few people came to me and asked me about doing that, and I told them, and there was a few of them that just went, thanks for your time, no worries, I'm out.
I mean, that's the thing. There's like a lot of ideas, there's this romantic perception of things and glass half full, rose-coloured glasses and whatever else I can think of. But at the end of the day, there's this huge commitment.
Huge, yes.
And if you're not willing to embark on that huge commitment and what that means to you, your family, friends, etc., from a time perspective, because that is our most valuable asset.
It is.
Don't go down that road, especially now. It just seems to be getting harder and harder for companies, doesn't it?
Yeah, and interesting you say that, is that year on year, there has always been something that was there and has changed. And it might only be something small, it could be something big. There's things that have been there that we do, and we sort of count on being a business owner, that we go, right, that's something that we have as an advantage as opposed to being an employee. That will change. Something else will get introduced, the ATO will change their rules, other legislation will come in or whatever else that's there. And you go, oh, we don't have that anymore, damn. But there might be other things that are still good for having your own business. So it's just sort of weighing it up. And I've seen people do this from time to time as well. They'll have a business, they'll actually go and be an employee for a few years. And then they'll either stick with being an employee or they'll come back and restart the business or something like that.
I think it's probably a good idea if you are running a business, obviously, to experience being at the other end. I had my own business many years ago, not in the renewable energy industry, only for a couple of years. It's young and stupid and broke even, but went, don't know. Now, I'd like to talk about some personal stuff. I know you're involved with the life-saving scene in Queensland. Can you tell us a little bit about that?
Okay. A little bit involved. That's one way to put it. Okay, so in 1990, I had a couple of mates at school who were involved with the surf club over at Stratty at Point Lookout. And I was a 14-year-old. I enjoyed being at being in the surf, surfing, all that sort of thing. And so they said, hey, come over and join the surf club. Get to stay for a weekend, get your awards, do patrols, do some cool stuff. I went, oh, right, cool. Came over as a 14-year-old, started training, got my bronze medallion in February of 1991, and essentially been part of the surf club ever since. Not only, a patrolling member of the surf club. By the way, big shout out to Point Lookout. Go the Point. Go the red, white, and blue. Love them. You are part of a family in that club, because we're over on Stratty, we all travel over there, together, so to speak. We stay for a weekend and we come home again because, being over there, you have to stay there. I mean, you can do day trips and stuff like that, but it's still one of the more traditional surf clubs that has, the bunk rooms where you can stay for the night and everything as if you are a club member. And so through that period in the 90s, I held different positions as a young man, as a teenager / young adult, and got, and we talk about mentorship and that sort of thing, that the amount of mentorship that I got there was amazing. Had some absolutely fantastic members there. And I learnt so much. I mean, one of the key skills that any person can have is how to save another's, like how to save another life, like, basic first aid, basic CPR. That, I've utilised that so many times throughout my life. It's not funny. Oh, yeah. And so, and then, I was involved in different things with the club, different, competition, life-saving, administration. I was a position holder with a couple of different things there, and just grew up with the club. I mean, I started, and then Mum and Dad got involved, and then my brothers got involved.
Wow.
And so we were all part of it there in the 90s especially. It was really good. And they sort of got to a certain age. My brothers, the two younger brothers, they're both electricians as well. So they did their time with Dad too.
Nature. Sorry.
That's all right. And so, so look, the progression through life-saving, they say life-saving is a journey and there's pathways that you can go down depending on what you want to do. With the life-saving side of things, I was, a patrol captain, an IRB driver, like IRB inflatable rescue boat, like the rubber duckies.
Oh, okay.
Yep. In the last, for the last 15 years, I've been a wave runner operator, so the jet skis.
Oh, wow.
And between 97 and 2003, I was a crew person, crew trainer and patrol captain with the Westpac Rescue Helicopter Service on the Sunshine Coast.
Wow.
So, got to patrol the Sunshine Coast.
You're jumping out of helicopters and stuff.
Jumping out of a perfectly good helicopter to go and save other people.
Yeah, wow.
Yes, and that was some of the best experience that I've had in my life. I learned so much. And, still there are people in the organisation today who are, still part of the chopper where when we were involved together.
Wow.
And they are involved now, and I still catch up with them every once in a while, and they went, good old days and that sort of stuff.
Yeah, well, good stuff.
Yeah. And so not only that, I brought my kids through. Hang on. Quickly as well, Amanda, she came over to the surf club and joined as a young member as well when she finished high school. And that's where we sort of, we knew each other at high school, but that's where we got together, was at the surf club.
Wow.
And so she came through the surf club as well too. She was a surf girl back in the day. And so, raised money for the club, promoted women in life saving, that sort of stuff. And it was very big at the time. So then we sort of came through. We ended up having our first child in the middle of me studying in 1999. And so a few years later, she got old enough to become a nipper.
Oh, wow, yeah, the nippers.
Yes, and the junior activities.
Yes.
That's right. And so, and we had the two kids at the time, and so we enrolled her into nippers. And so we got sort of, we were busy with family and other stuff that was happening at the time. And so we got back into the club, more full-on basis with the junior activities. And so we came through, and our kids were coming through, and, because I'd had the previous experience with everything on the beach and the patrols and stuff, so I became what they call the chief water safety, which is essentially the person looking after everybody in the water and around the beach, and the safety and the coordination of the
shark.
Yeah.
No.
Yes, yeah.
Did that happen?
Yeah. It happened every once in a while. We'd be there, and somebody would say, "Oh, we think we saw something," and so we'd send out the boat, and we'd have people in the water and kids in the water and stuff, and we'd have to get them back in again.
Were they netted beaches? These
No.
ones?
Oh,
Okay, yeah.
We've just got the hooks off the shore, so no nets. But hey, look, it's we're in their environment.
Yeah, of course. That's the way I look at it. Yeah.
Yeah, and so no, it was there's never a question of safety with regards to the kids in the water and that sort of thing. And then we would the kids came through, and we would go over on a Saturday with the NIPA program, and it'd be a full day. We'd go over as a big group on buses, and have a lot of fun, and basically mates for life, and and a lot of the kids that were there with my daughter's age, like with my kids, they're coming through and they've been through in the surf club. And it's interesting because those kids now have got their own kids and they're coming back in.
Yeah, wow.
So it's this big...
It's a generational thing,
exactly.
Yeah.
And so during the time that our two kids were in nippers and coming through, we ended up having another couple. And so that just extended our time. So we were nipper parents there for 17 seasons.
Oh, wow, yes.
I think at the moment, we hold the record.
I was going to say, did you have held a record?
I think so.
Yeah, wow.
I think it's. I'm sure that there's a couple of other people that have been around that time as well. But I was chief water safety for a lot of it and helping out and just helping run days and whatever else. And the last 3 seasons, I became the chairperson for the junior activities. So I was the nipper director, and so.
Wow.
Being in charge, that's a scary thought. But it was great. We had
no comment.
No comment. No, but we had amazing people, an amazing team, and it was funny because I agreed to do the NIPA chairperson 2 weeks before the first lockdown was announced in 2020.
Wow. And
so we have what's called the off season, and we work across the off season to get everything ready for the next season. And that off-season was the hardest that all of us have ever worked, and that was the biggest challenge that we'd ever faced as an organisation. How do we actually run a sports program? Because a lot of the winter sports on 2020, they all got cancelled. It was just too hard, and they just went, no, we're not actually doing this. And so we worked for 3 months solid, multiple meetings a week, going through programs, and as things change, we'd have to readapt and redo all of our policies, procedures, all this other stuff as well too. So when we actually got to the start of the season, we were ready, and we got set up. We did it all, and proud to say that, like I said, we had an amazing team. We didn't lose a nipper day to COVID.
Wow, that's fantastic.
We lost a couple of competition days, where they'd go to like state titles or something like that. Unfortunately, they would. The first state titles, which was right at the time when they announced all the first lockdowns, we lost it there. But for a standard nipper day, we never lost a day to COVID, and it was because of that whole management of that particular issue with myself and the team. They were amazing. They were so good.
I know you have other passions, and we've talked about them, but the one I'd like to talk about now is, and I'm not a beer drinker, but I drink wine, but I love the process. I like the idea of people actually creating their own beer and their own wine. And you've been doing it for a while. So tell us a bit about that. And also, do you apply engineering principles in regards to that process procedure to your beer making skills?
Of course I do.
I knew that. I knew that.
And so, okay, so I worked for the breweries for 5 years. And when I worked for the breweries, not only did I get to see a lot of the process, but they would send you on little short courses.
Right.
And so you would get to learn more about packaging. You would get to learn more about the brewing process. And part of that brewing course that you did, you would learn about all the different aspects about it and some of the chemical stuff behind it too.
Right.
And they had this guy in the organisation, apologies, I can't remember his name, but he was the one of the brewers, and he knew everything there was to know about yeast. And he just was amazing. It was so good. And so, you'd listen to these people and how much passion that they had for brewing, and you really loved it. Like, it was really good. And so I'd learned more about the brewing process when I actually worked at the brewery. But I was never a big beer drinker.
Right.
And so I would have a few beers or something like that, and I would wake up the next morning and just not feel great. And so hangovers for me was pretty bad for a while.
Right.
And so anyway, fast forward a few years, mum and dad were living in not far from where we lived, and we were over at a mate's place, and he homebrewed. And so, and he said to me, "Oh, look, come over on a Sunday," because he knew that I'd sort of have, I'd have a few drinks on a Friday night, and then just the rest of the weekend I'd feel like crap and everything. And then Monday I'd just still be not feeling the best. He said to me, "Come over on Sunday afternoon, we'll watch the footy, we'll have a few beers, and we'll see how you go." I'm like, okay. So went over, had quite a few. Luckily I was able to stumble home. And the next morning woke up and went, wow, I feel amazing. That was just nothing like the other beers that I've had previously. And so I went back to him and went, okay, what do I need to do to actually start homebrewing? And so he talked me through everything. He showed me.
Can I ask why you didn't feel? Is it what? Is it what they?
I don't think. Look, different people have different reactions to different substances. Alcohol being one of them. Is that you get some people that can handle it really well. You get others that they have a couple of shandies and that's it. They feel like crap for the next few days. And there's people actually out there that are allergic to alcohol.
Yeah, I've heard that.
Yeah,
it's a poison technically.
Well, yes. Well, it's a depressant, and then part of the breakdown, and I think this is where it came into it. Part of the breakdown of the alcohol that your body does, I think it's a 2-stage process.
I don't know.
Yeah, and it's that first sort of intermediate stage where it converts all the alcohol into, I'm going to say formaldehyde type stuff. Or no, there's a specific name for it. Sorry, can't remember it at the top of my head right now. But it's that stuff that actually makes you feel like crap. And so if you've ever had a few drinks and you wake up 3 o'clock in the morning, sweating, awake, that's your body sitting there going, hang on, I've converted all the alcohol now into that crap. And essentially you're being poisoned right now. So wake up, shot of adrenaline, sweating, you're trying to get rid of it, drink some water, go to the toilet, whatever else you need to do, and then go back to bed. So anyway, I guess it's me.
Yeah, but I thought what I'm trying to ascertain is that you had a few drinks of this like commercial product. I thought there was a difference between the commercial product and the home brew.
Yes, there is.
So what's that difference?
Well, so commercial beers are made to certain specifications,
right?
And they have to have a certain amount of shelf life. And so if you take some, well, it's not only that; it's also some of the processing that goes into it. Like there's a lot of filtration,
right,
clarifying of beers, and just making sure that they manufacture this beer in one place and they send it out, for example, all over Australia.
Yep.
And there was the joke at the time, or not at the time, but one of the jokes was that they would ship the beer to Darwin and Alice Springs, and it would take a bit of time because it would go by road and rail and everything like that. And then they had an issue up there with some of their storage, and so they had to basically take a whole heap of stuff straight from the brewery, take it up there to replace the stuff that got lost.
Right.
And everybody started drinking the same beer, but was going, oh, what's up with this? It tastes different. And because of the fact that it had come straight from the brewery, it hadn't had a chance to sort of sit and mature and be exposed to higher temperatures.
Because we're talking about a living product, aren't we? It's not...
Well, that's the thing, though, is that with some of the beers, you have pasteurised versus non-pasteurised.
Right.
So if you have a look at your standard beer, on the side of it, it has a best before date. For example, if you look at a Cooper's beer,
yep,
or some of the other beers, especially Cooper's, it has a best after date. And this is one of the main differences with homebrew.
Right.
Is that you manufacture it a little bit more au naturel. And after a certain amount of time, it actually matures and gets better. So if you can store it at the right temperatures, then in theory it will last a lot longer.
Homebrew.
I
Thought you would say the opposite.
No.
I mean, wow.
If you can store it under the right conditions, homebrew can last a long time.
Okay.
And it gets better. So with my process is that I've got a storage area under the stairs in my house, which is perfect temperature control. Stays pretty well the same temperature the whole year round.
Wow.
And that's where I store my kegs and have them mature. And so I have a few kegs, where I can get maybe 2 to 3 months worth of storage or maturation. So I can then bring them out, put them in the fridge, and then essentially start taking from them, and they're really good. Especially the lagers. The lagers over time, they get better.
Have you ever tried making meads and things like that?
Well, funny you should say that. Not so much a mead. I mean, mead is more of based on pure honey. But I do a honey wheat.
Right.
And I've just done one recently.
Right.
Use the honey from our family who have their own beehives up in Cairns in the rainforest there.
That'd be an interesting honey.
Oh yeah, it's lovely.
Wow.
But yeah, so it's a honey wheat mix.
Yep.
That is very nice. And so so different beers. Everybody's got their different tastes, different palates, and so I brew what I like.
It's a universal drink, though, because virtually every civilization has brewed a kind of beer, in addition to what wine from fruits or grapes or what have you. But everyone's basically done a beer. There's a Korean beer called makgeolli, which is pretty interesting. It's like a milky looking weird beer that fizzes a bit in your mouth, and it's fairly strong, not as strong as their soju, but it's always fascinated me. As I said, I don't drink beer, but I love the idea. I've got some vines at home. I want to make some wine one day when I get enough grapes, because there's not many of them. But I like the idea of making your own. It's very satisfying. Very satisfying.
Oh, it is definitely, and it's for me. It's my we talk about mental health and having good spaces to do what you enjoy. That is my, lock myself away for a few hours, go and do some brewing, and I come out the back of it, as long as I don't stuff things up too badly, where I'm kicking myself or I did something dumb, you get a good result, you're actually very happy with yourself, and you go, you know what, time well spent.
Do you write stuff? Are you assiduously writing every detail? And because there's a lot of factors in it, like a temperature of 22, let's say a temperature of 22 degrees for 5 minutes is different from 21 for 3 minutes.
Yep.
And that all plays a role, doesn't it?
So, okay, so going back to doing the homebrew setup is that I bought a basic kit under instruction from my mate. And so, he was really good in how you would actually set everything up. And Lyndon and I, we always talk about beers and stuff like that. He's absolutely fantastic. He still does his. And so started off, sort of got things right, read on things, improved, and just developed over time. And then I got to a certain point where I went, okay, I'm just going to change how I do my fermentation, and did that. Changed a few things. Yep, okay, that works really, really well. Then I said, right, I'm going to go away from using the tins. I'm going to go to all grain. So bought all the equipment to do that. And it was very hit and miss to begin with. Took a few goes to get it right. But, you talk about writing things down. I did that. I had the portable temperature probe and the pH probe and all this other stuff where I would essentially be recording all the details of a brewing process and making sure that I'm trying to stick within the limits, and then making sure my additives and my water and all the rest of it was right. Because if you don't do that, we go back to front end loading projects and stuff like that. If you don't do it properly at the start, then there's no point.
Absolutely,
you're going to stuff it eventually. So you do all that at the start and make sure that it's all good. And you eventually get the process down where I can do it now because I've been doing it for quite a few years. I can just go, righty, I'm going to do a pale ale this week. I know what grain to get.
Yeah, right.
I know what yeast I need. I know what my water
You know
profile
the
is going to be.
variations required, yeah.
And so I just go, right, okay, this is what I'm going to do. And I can do it like now with just reading back on what I do. Yep, okay, cool. Follow that procedure.
Do you think good beer making is natural? No, I'm joking. I wanted to make sure I put that in at least 3 times. So, look, I love the idea, and I actually wish I consumed beer, because when I hear people talk, especially the honey wheat beer, because you know I've got hives. I'm the world's worst beekeeper, by the way. I am so bad that I got a friend of mine in Queensland, Koroit, to send me down a nice jar of his honey, which is superb, right? It cost him a fortune packaging, but anyway, he's a good mate.
Good.
Because my bees are still alive and they fertilise the garden and stuff like that, but I haven't had any honey for the last 2-3 years. But yes, and I'm scared of them. So, but we won't go there. I'd like to jump back to some nitty gritty stuff concerning this commercial solar. The whole thing about cable tray and cable. We were talking off camera before about the standards, and they're living documents. They've always been improving. But the whole thing of cable in tray and the cables actually touching the side of the tray. There's nothing in the standard and the calculator to show that, you know.
There's a difference between that cable sitting against the side of the ladder or the tray versus sitting in the middle.
Yes.
That's right. So I guess what you would do with that is have a look at your theoretical airflow around that cable and being up against the side of it. Like if you've got high side cable ladder, potentially that could be listed as being on installed on a surface. Not saying it is or anything like that, but your overall spacing between your cables and your rungs and the ladder might actually help out with that. But just bear it in mind. Another thing too, and have a think about this, is the differences between installing ladder or tray horizontally versus vertically.
Yes.
And I've seen this before where if you install it vertically and you've got that cable tucked up, right at the top, touching the edge, is that cable actually gets very warm.
Especially if it's got a lid on it.
Especially if it's got a lid on it. But never mind the lid for a second, but you've got these cables underneath it where the heat's going straight up. So you actually get this gradient of heat with your conductors. And I've seen this before on a single circuit, like a single high current circuit, that you've got the 3 conductors and the neutral, is that each of those active conductors, like the first one will operate at the theoretical operating temperature. The next one up will be warmer because of the contributing factor of the heat rising. And then the third conductor, is even going to be hotter again because of the fact that you've got that heat just going straight up.
Because that what you just said applies to nearly every cable tray configuration between the inverters and the PVDB. Hardly ever you're going to see them in a horizontal tray.
Well, that's where, like I said before, figure 1B and 3008, that's where I think it's on the vertical, it might be 2 diameter spacings. You're trying to separate those cables out and trying to keep that airflow going around them. So just have a look at what the configuration is and say, okay, is that ideal? Can we improve it? Is there a better way?
And can we improve it within the confines of the economic reality? Because we want to make money on this project.
Exactly. Balancing act.
Balancing act.
Balls in the air, juggling. And all
absolutely.
that sort of
and I back to juggling. You mentioned before you can do three. I could at one stage when my son learned it at school, and it takes a while. You feel like an idiot at the beginning, and we started with hankies just first, and then bought the juggling balls. But it's quite fun. All right, we'll move away from tray because I think we've covered a lot of cable and cable tray. Let's talk about inverters.
Yes.
And also the fact that, actually invariably going back to cable, in some situations you don't have to run a neutral from the inverter. Now, is it a case that, hey, if there's a attachment, a connection within the inverter, a compliant inverter, and there's a neutral attachment, you use a neutral. If there's none, you don't? Or is there other rules and regulations? I know this is a bit of an interest, it's a complicated area, Gil.
It is.
And I'm sure it'll be brought up in the training at
Yes,
some stage,
yep. Well, not only that, I'm hoping I can give a good answer.
Please.
And there will be obviously different thoughts on this out in the industry, and that's all good. Okay, so take it as being just a black box that we're connecting up to a supply.
Yep.
And look at it from terms of what are we actually going to do with this. And I'm sort of thinking about it in terms of it's a solar inverter, it's a motor, it might be a heater bank, it could be a whole heap of different things that in some cases, for what you're doing with it, you may not necessarily need a neutral. So, for example, three-phase motors, they don't need a neutral. Heater banks, for example, they don't need a neutral, depending on how you're running them. So similar sort of theory is that you are assuming that your connection between your three phases to a central neutral point is maintained at a switchboard or somewhere where you've got, obviously supply coming in from your transformer, trying to keep things balanced, because as soon as you start throwing things out of balance with your three phases, you actually shift that neutral, either towards one phase or away from two, or it depends on the configuration and network impedances and current flows and all this other stuff. So, when you're looking at that, having that neutral at the inverter might just be something to do internally with the inverter itself, or it could actually be something to do with how the inverter needs to generate its supply and push the power back out onto the grid.
At the end of the day, there has to be an MEN link, there has to be an earth, there has to be a neutral somewhere.
Yes.
And I know with on HV sites, there's the neutral within the transformer. Is that right?
Yeah, so where you step it down to low voltage, yes, you've got your three phases, your neutral, and some form of neutral earthing for most installations. If you have some other thing that you might need to do, like it might be a mine site or something like a higher voltage supply, you might not necessarily have that neutral reticulation. You might have a resistor, you might have a reactor, you might have some sort of impedance earthing scheme.
Right.
And it gets into a whole different realm
of
earthing. Yeah. And so where you're looking at a standard supply to a site, you've got your three phases and your neutral being reticulated around. For a TNS system, you are earthing it at one point and one point only. For a TNCS, which is what our standard AS3000 distribution scheme and your houses on the street type scenario, that's a TNCS is an MEN. It's a true MEN, multiple earth neutral system, where you are earthing the neutral at different points, even though you are reticulating that around your supply. So that has different functions. So, for anyone to say, okay, there's a rule of thumb for neutral and neutral earthing and earthing, no, it's not the case. It changes depending on your application.
I'll give you an example. 400 volt nominal, 9 sun grows, interface protection, transformer stepping up to 22 kV straight to an RMU, ring main unit.
Yep.
No neutral required on those particular inverters. Now, you've got the quizzical look, but...
RTFM?
Well, yes, absolutely. Read the data manual.
Yes.
It's so there's what I'm trying to say. It's up to, I suppose, the distributor has a massive role to play in whether they accept it or not. But isn't it the overriding scenario that if the inverter itself has a neutral connection and it's compliant, you're going to use a neutral. If it doesn't and it's compliant, there's nowhere to connect a neutral into the inverter. Is that what it comes down to at the end of the day?
At the end of the day. So if we look at certain things, if we look at our structure of how we have our connections, obviously we have our legislation, we have our standards. In our standards, we have AS NZS 3000. Where we have NZS, AS NZS 3000, underneath that, and bearing in mind that 3000 is an umbrella standard.
Yes.
And a whole heap of different standards fall out underneath that.
Yep.
And so you've got 4777.1, which is all about how you connect in inverters into an electrical distribution system. So if you have a look at 4777.1, in a lot of instances, they say use the manufacturer data or guidance out of AS NZS 3000.
Yep.
So this is why I keep going back to RTFM, because that's generally the first place I'll
yeah,
actually look.
Yeah, gotcha.
As to how you structure this properly. So where you have these types of connections and scenarios and everything, inverters are just electrical equipment that you are connecting to a distribution supply. The overriding principles of safety, compliance, will it do the job for an electrical installation is what you need to adhere to. So neutral or no neutral, that's just one element of safety or compliance that you have to take into consideration, whereas all the other stuff that's there has to obviously go by the standards. So it's interesting. It sort of, where we talk about that, and I'll quickly sort of go across to this very, very, very quickly, is that there's a point where you say compliance with the standards may not necessarily be compliance with the legislation.
Right.
So there's things in here from an overarching perspective that we need to do properly for assessment, whereas the neutral to inverters is just one element of it.
Right.
There's so much other stuff in there.
Boy.
And it all has to tie together correctly.
So really, at the end of the day, and I'm always trying to find some kind of statement that covers, and in most cases it does work. You're talking about, I don't know. I actually don't. I'm flummoxed at the moment. Yeah.
Okay, so
yeah.
where we talk about, for example, a neutral connection into an inverter, there might be other elements that we need to take into consideration. That might be there for protection. Protection is the overriding side of things. So if that neutral is supplied to an inverter, if the inverter manufacturer says we want a neutral there because if there's an internal fault,
yes,
then we just want everything there to try and keep it our phases balanced, or have low impedance path for, like, if it's a neutral,
even if the fault is
fault,
200 milliseconds or something, it's still...
It's amazing what can happen in 200 milliseconds under fault conditions.
Yeah, right.
Yeah, there's a lot of things, and depending on whether or not that it's high voltage, low voltage, could be some lightning protection, that sort of stuff. There is so much different variability with all regards to this. Where you have your supply being reticulated through, it's very important that is connected correctly, and that all the fault protection side of things is all taken in consideration. Where that inverter has a neutral may be listed there by the manufacturers for protection and functional requirements. And if you look at requirements for electrical equipment, protection is the thing that we are trying to achieve primarily. If there's secondary or tertiary functional or other requirements, then we have to go with the highest, the highest priority one.
Is this what, like, as part of a protection study, is this what the PowerCAD takes into consideration? It looks at those things as even that nitty-gritty with...
Well, it looks at, for example, if we have inverters that are installed a certain distance away from a switchboard, that our protected device is properly rated, protects the cable in the event of a fault at an inverter, that it will protect the cable, it will automatically disconnect the supply, so trying to remove the faulty part of an electrical installation while keeping the rest of it online. And making sure that time, as you said before, that 200 milliseconds, safety-wise, we have the rule of thumb in AS NZS 3000 that an earth fault go no more than 0.4 of a second. Ideally, we're trying to cut that as quick as possible, because it could be that you're standing there doing something on that inverter or close by where that fault causes the earth to rise in potential. and then you become part of the earthing system.
Yeah,
and
right.
This is where we have issues with it, with EPR, touch voltages, all this other stuff too, where you are, trying to protect personnel first, and then equipment and installation after that type thing.
There's so much, isn't it? I mean, that's the
Yeah.
thing, Gil, and I'm really glad. I mean, we both agree we could talk for another 3-4 hours on all nitty gritty. I can't wait to see you up at the training.
Yep.
And I'd just like to say thanks so much for flying down from Brisbane today to take part in this podcast.
Mate, thank you so much for having me.
It's always fun when we get together and chat about things. So thanks very much for that. Cheers.
It's all good.